Hi everyone, let's talk about finding the number of digits of an integer using the tool of logarithms. So in general, what we're trying to do is that if we have an n, which is a positive integer, what we want to do is find a function fn let's say fb of n, that outputs the number of digits of n in base b. So what we're going to do is say let n equal to xm minus 1 all the way through to x1 x0 in base b. So there are m plus 1 digits. And m could be 0, so that means there will be just one digit. So we're trying to find m in terms of n, and we want fbn is equal to m plus 1. So really we're just looking for m, and we can just tack on a 1 in the end. The main insight is that each xi, since it's in base b, is less than or equal to b minus 1 and greater than or equal to 0. And the second insight is that xm, the highest digit, has to be greater than or equal to 1. It can't be 0, because by definition we don't allow the highest digit of a positive integer to be 0. Then it would be a lower digit or lower place digit that would be the highest place digit. So using these two, we can make some good progress. So we're gonna do the base expansion here. We get xm b to the m plus xm minus 1 b to the m minus 1 all the way through to x1b plus x0. And first of all, this is going to be greater than or equal to this term. We can make the rest 0 as a lower bound. We get 1 times b to the m, which is equal to b to the m. As for the upper bound, what we get is that it's less than or equal to b minus 1 times each of the coefficients, b to the m plus b to the m minus 1, all the way through to b plus 1. And by the difference of powers factorization, this is just equal to b to the m plus 1 minus 1, which is less than b to the m plus 1. So let's summarize that. We know what we know. This is just n. So what we find is that n is less than b to the m plus 1 and greater than or equal to b to the m. So we can take the log b of both sides and get m is less than or equal to log b of n, and that's less than m plus 1. And by a property of the floor function, we find that the floor of log b of n is equal to m. So the number of digits, including the units digit, is equal to m plus 1. The plus 1 accounts for the units digit, which is equal to floor of log b of n plus 1. So that's our final answer. Thanks for watching, and I'll see you next time.